All right, hey guys, hopefully this video comes through well enough. This is going to be our notes on function, domain, range, and solutions. Algebra 1A, Unit 2.1 notes. As a quick heads up, John von Neumann is our mathematician for the day, Hungarian American mathematician. Should look him up sometime because he has a huge amount of work behind him. Mainly we know him for the Manhattan Project, as well as putting his name on dang near every topic in math that we end up studying. Um, so to get into the notes for today, our objectives are to be able to communicate to a partner if a relation is a function. Those are both vocab words that we will explore during this lesson. We are going to be listing the domain and the range of a relation. Again, vocab words. And determining if a coordinate is a solution for an equation. A lot of vocab words in this one. You'll notice that most of our first lessons within a unit end up being very vocab heavy. So to get some of those definitions out of the way, a relation is just anything that relates two elements. Now, when we are thinking about a relation for this class in the scope of what we're doing, I want you guys to think about it as a coordinate, x comma y. You've seen these at some point before. We are taking an independent variable x and relating it to some dependent variable y, and we pair them together in a coordinate. Now, if we were to break that coordinate apart and look at only the x values, we would be talking about the domain. So the domain is just the collection of all x values. So we're going to have a list of these put out. You go through, you pick out each of your x's. Together, we call them a domain. A way that I like to think about it is singular versus plural. We have a student versus a class of students. An individual x is just an x, but when you have multiple x's and you're naming all of them, we call it a domain. Let me slide this back up. Next vocab is range. If we have a word to communicate all of the x's, range is the way that we communicate all of the y's. So the range is just the collection of all y values. So here's some basic vocab to get us started with it. An example that I might draw out, we use this symbol. It's a curly bracket to contain a group of things. So let's say I contain the coordinates 1, 2, 3, 4, and 1, 8. If I was to go through and look at each of these coordinates, I could graph them, but if I was just picking them out, I would notice that each one is in the form x comma y. So I have an x, and an x of 1, 3, and then 1. And alternatively, I have a y of 2, a y of 4, and a y of 8. So if I was to list these, I would have my domain, and I just use a capital D to represent domain, of 1, then 3, and then another 1. If you think about building a list, when you have something repeating on a list, you just don't bother writing it again. So in fact, I'm just going to get rid of my comma there. It's just the numbers 1 and 3. Range works the same way. With the range, I am picking out the y values. So I have a 2, I have a 4, and I have an 8. So these aren't directly used in themselves. It's just a way to kind of pick out values from a list. Now, when we're actually going to start using this is where we come into it next. Function is going to rely upon some of these. A function is a relation. So it's coming back to this vocab word earlier. It's a relation where each X value is unique. You'll see a lot of different definitions for this. There's not really like one perfect answer depending on the class that you're looking at. I like to just try and talk about it in terms of uniqueness. You may see some people say once and only once, something along those lines. For the sake of what we're doing, this is kind of how I'm going to focus it. The goal when deciding if a relation is upgraded to a function is you look at the x values and you ask, is there any point at which an x value is repeating? Now, by that, I mean, is it being listed in two different coordinates? So what I would argue, if I look at this example, I see 1 as an input with 2 as an output, and I see here 1 as an input with 8 as an output. That would be a situation where I would say this is not a function. And so the idea of a function really boils back to, can I reasonably expect what I should get as an output with a given input? So if I know that I'm going to be using 1 for my x, can I guarantee what is going to be coming out as my y? In this case, I can't, because if I put in a 1, I could either get an output of 2, or if I put in a 1, I could get an output of 8. I don't know which one I'm going to get, so I don't trust this relation. And that trust is the fundamental part of what builds a function. In the case of 3, I guarantee that when I put in 3, I would get a 4, so that's not really a problem. I circle these because those are the parts that break it for me. Okay, so moving on down the page, and feel free to pause this as needed, or time to catch up or to work with it. We got a few more examples to look at. We're going to list the domain, we're going to list the range, and we're going to decide whether or not it's a function. So 9, 10, -5, -2, 2, -1, and 3, -9. Might be a good thing to pause here and ask, do we think it is a function or do we think it's not a function? And what do we think about the domain and range? For the domain, we're going to list the x values. So if I go through and pick out the first number in each of these coordinates, I've got a 9, -5, 2, and 3. For range, I'm going to list the other values, the y values. 10, -2, -1, and -9. Now that I have my domain and range written, we need to then ask, is this or is this not a function? So keep in mind, we're trying to see, is each x value going to be unique? Do I see it only once, or do I see it in such a way that it's not going to cause a problem in trust? I see 9 is going to 10, -5 is going to -2, 2 is going to -1, and 3 is going to -9. I do not see any x value being repeated, therefore it is unique, so this is a function. Moving down the page. Again, feel free to pause to think about it. My domain, 6, 8. I've got a 6 again, so I don't need to bother writing it. I've already got it on my list. And a -2. Range, we've got an A, we've got an F, we've got a B, and we've got a P. Now, this is not something that we would be graphing in this class because we don't really graph letters, but a relation just takes two things and compares them to one another, so letters are fair game. So we've got all these written out, and again, might be a good idea to take a moment and ask, is this or is this not a function? This is not a function. And the reason for that, we have an input of 6 going to an output of A, and we have an input of 6 going to an output of B. 6 is being used twice. It is not trustworthy. If I was to give this relation a 6, it might give me an A or it might give me a B. So I'm going to say is not a function. One last one to do for relations. My domain, Z, Y, R, Z, K. My range, 7, -5, 7 again, 0, and 0. Now, hopefully someone was yelling at their screen to tell me to stop writing things in repetition. I've made a mistake. So, worst case scenario, I try again. So hopefully you didn't fall for it and write it down. My domain, I need to stop listing things in repetition. I've got Z, Y, R, another Z. Why would I write that? I've already got it written. K. And then for my range, 7, -5, 7, already written, 0, and again a 0. So that is actually what my domain and range should be. I'm not going to attack you if you happen to write some stuff in repetition, but why bother with the extra work? The whole point of being in math is that we're trying to do it as lazy as possible. Let's get that done. Now, as for whether or not this is a function, some people get thrown off about why this may or may not be a function. I will tell you that the answer, it is not a function. But the question is, why is it not a function? What in particular here is preventing it from being a function? Well, to zoom in, we have Z of 7 and Z of 0. This is actually the only coordinate that causes a problem because the Z is repeated. Z here, Z there. Z of 7 and Z of 0 would result in not a function because I can't tell if Z should go to 7 or Z should go to 0. Some students have a habit of trying to tell me, oh, but I see 0 repeating here and here. Well, it's not a problem to be repeating in the Y values. If you think back to our definition from earlier, we said each X value is unique. So we're checking only the domain, only the X. We're going to bring it back down. We have one more thing to cover in this lesson, and then we're done. Solution is the last vocab we need to practice. A solution still is dealing with coordinates. So it's still dealing with X, Y. But it's going to be used. We're no longer just studying it and classifying it, domain and range. We're just going to use this coordinate. It is an XY that results in a true statement. And of course, I ran out of room when plugged in. So it's an X and Y that results in a true statement when plugged in. Now, what I mean by that, every coordinate, as we mentioned earlier, is made up of an X and a Y. And we have an equation here that we are going to plug these numbers into that equation. So instead of Y, why not write 11? We have 2 times X. Well, instead of X, why not write the 4? As long as we know a solution or know a possible solution, we can just plug in those values and try to get an answer. So 2 times 4 is 8. 11 equals 8 plus 3, which I would argue is a true statement. 8 plus 3 is 11. So as soon as I can guarantee that, and I say, yep, that's true, I can say that 4 comma 11 is a solution. That's the whole point of it being a true statement. When you plug it in, see if they equal one another. As long as that answer is yes, you say it is a solution. And vice versa, if the answer is no, it's not a solution. So bringing it over here, again, we have x and y. 2x is going to be 2 times 5 minus 3y, 3 times 0, equals 13. Simplifying this, 2 times 5 is 10, minus 3 times 0 is 0, equals 13. Now, I don't know about you, but I'm pretty certain that 10 minus 0 is not going to get us a 13. So in that case, if they don't equal each other, we can put a slash through it just to say not equal. And if it's not a true statement, we are going to say that 5, 0 is not a solution. All right. From there, you should be able to move over to the assignment. I hope everything goes okay, guys. Bye.